So last time we discussed about resistance, that resistance is the hindrance in the flow of electrons, right? So जो भी आपके पास flow of electron में hindrance होगी उसे हम resistance से represent कर सकते हैं और resistance is a quantity which produce hindrance in the path of charges or in the path of electron flow, right? So today we will discuss about the factor affecting resistance, right? So if we discuss about the factors affecting resistance, so what are the factors on which resistance depend, or you can say that on which factor or by using those values, how can we increase or decrease the resistance, right? So today we will discuss about the factors affecting the resistance in a circuit. So let's suppose if resistor is connected in a circuit and if we take example of a wire, नॉर्मली आपने देखा होगा कि नॉर्मली हम वायर्स स्ट्रेट यूज करते हैं, राइट? और अगर वायर्स में बहुत ज़्यादा लूप हो, इफ देयर आर मैनी लूप्स इन अ वायर और वायर इज स्पाइरल इन फॉर्म और देयर इज सम round in the wire, so first we need to straight that wire, then we plug in into our power supply and we use that wire, right? So उसका रीजन क्या होता है हमारे पास कि हम वायर को स्ट्रेट करके क्यों यूज करते हैं नॉर्मली, हम उसे राउंड या कर्व क्यों नहीं यूज कर सकते? या बहुत ज्यादा अगर स्पाइरल होता है हम यूज तो करते हैं, कोई इतना इशू नहीं है, लेकिन उससे इफेक्ट क्या होगा?
The flow of current.
यस, द फ्लो ऑफ करंट जो है वो इफेक्ट होगा। लेट सपोज अगर आप पॉइंट ए टू बी आपने मूव करना हो, पॉइंट ए टू बी इज द point A is the starting point, B is the destination. So the simplest path we use to travel from A to B is the straight line, right? And if you travel this distance in some circular or in some spiral form, so which path is the longest one, the green or the blue?
Green.
Green takes much time to complete path between A and B because B is, or green color is spiral in form. It means that if we make this a spiral into a straight wire, so the length will be greater than the blue one. So same happens with the resistance of a wire, right? If there are resistor in the circuit, so that make hindrance in the flow of electrons. And let's suppose if wire or a conductor is in a circular form, or let's suppose there are many loops in a wire, so that affect the value of current in the wire. So first factor we discuss about is of length. So if we discuss about length, so what is the effect of length on the resistors? If we increase the length, so what do you think that length will increase the resistance or decrease the resistance?
Increase.
Increase the resistance, right? Because same goes here for the path from A to B. Because अगर हम length increase कर रहे हैं तो हम charges के path को increase कर रहे हैं travel करने के लिए, right? So if we increase the length, so resistance will also increase. So we can write as resistance is directly proportional, is directly proportional to the length. Directly proportional means if we increase one quantity, the other quantity will automatically increase, right? And the relation between these two quantities are like R is directly proportional to length, right? And further अगर आप इसको लिखना चाहो, so greater the length, So greater. So resistance will increase in. So if increase the length, resistance will also get increased. And if we take the example of power banks, तो नॉर्मली पावर बैंक्स में वायर स्मॉल यूज करते हैं, ठीक है, क्योंकि उसमें हमारे पास एक तो डीसी सप्लाई होता है, क्योंकि वहाँ पे ऑल्टरनेट करंट नहीं है, डायरेक्ट करंट है, क्योंकि उस पर बैटरी और सेल जो है वो इंस्टॉल्ड होंगे और उसमें चार्जेस यूनि डायरेक्शनल फ्लो होंगे इनटू वन डायरेक्शन. And if we use lengthy wires with power bank, so many of energy got consumed in traveling from power bank to the mobile phone, right? Because length is increased, so resistance will also increase, and that will affect the value of electric current to decrease, right? Any confusion?
No, sir, it's clear.
This is basic concept. That's why the wires of power banks are short as compared to the normal charger wire, because we need to save as much energy or much charges in our power bank. So that's why we use small length wires. If we discuss about the second factor, so second factor is of cross sectional area. So what will be the effect of cross sectional area on resistance? And first of all, let's discuss what cross sectional area actual is. Let's suppose if there is a conductor or a wire. This is a wire, and on 2D we can only observe the front side of the wire, right? Because we are not drawing this wire or conductor into 3D form. And if we want to look at the front side of the wire, so the front side of the wire is circular in shape or round in shape, right? Just like our normal pointer or pen, if we observe that pointer or pen or marker from the top of the marker or from the back of the marker, so you observe circular shape, right? And cross sectional area means that we are talking about this one, right? Because this length will also gives you the area of the wire or a conductor, but we are talking about cross sectional area. So cross sectional area is in the front of the wire, or you can say that the front face of the wire. So this will give you the cross sectional area, right? What will be the effect of cross sectional area on resistance? Let's suppose if you take example of a pencil and a board marker. So क्रॉस सेक्शनल एरिया किसका ग्रेटर होगा, मार्कर और अ पेंसिल?
Marker?
यस, मार्कर. ठीक है, तो क्रॉस सेक्शनल का आइडिया आपको क्लियर हो गया कि मार्कर का क्रॉस सेक्शनल एरिया ग्रेटर है, ठीक है, क्योंकि वो थिक है आपके पास, और पेंसिल जो है वो मार्कर की कंपैरिजन में थिन है, तो उसका क्रॉस सेक्शनल एरिया भी आपके पास शॉर्ट होगा. ठीक है, एक डिफरेंस हो गया. ओके, अब हम इसको रेजिस्टेंस पे अप्लाई करते हैं. तो आपका क्या आइडिया है कि रेजिस्टेंस इंक्रीज होना चाहिए या डिक्रीज होना चाहिए? अगर हम लेट सपोज क्रॉस सेक्शनल एरिया इंक्रीज कर रहे हैं, इफ वी आर टेकिंग थिक वायर,
Decrease?
if we increase the cross sectional area, so resistance will decrease, right? Okay, take another example. Let's suppose if there is a door in a classroom, and the volume or the size or area, whatever you say, is the first one. And if we draw the diagram for the main gate of the school, so now there are two different areas of gate. This one is of classroom, and this gate is of main gate. So if many students try to pass through the classroom gate and the main gate, so from which gate multiple students can easily pass through?
A main gate?
हाँ, मेन गेट। ठीक है, तो मेन गेट का रीजन ये है कि आपके पास अगर क्रॉस सेक्शनल एरिया ग्रेटर होगा तो चार्जेस इजीली फ्लो होंगे, राइट। और अगर हमारे पास क्लासरूम का गेट होगा, मतलब हमने क्रॉस सेक्शनल एरिया को डिक्रीज कर दिया, तो रेजिस्टेंस क्या होगी, इंक्रीज हो जाएगी। वहां पर क्या होगा, सब एक दूसरे को ओवरलैप करने की कोशिश करेंगे। ठीक है, और उस ओवरलैपिंग में क्या होगा कि आपके पास जो फ्लो होगा वो स्लो डाउन हो जाएगा। ठीक है,
Yes, sir.
तो रेजिस्टेंस विल इंक्रीज विद इंक्रीजिंग क्रॉस सेक्शनल एरिया। So we can write resistance will decrease with increase in cross sectional area, right? So it means that resistance is inversely proportional to the cross sectional area. So R is inversely proportional to cross sectional area. Okay, so this is another factor for that affect the resistance of a wire, right? And if we further
Yes.
discuss about another factor, so any other factor that will affect the resistance? Okay, so now if we combine these values, then the final formula we will get is in the form like this: R is equals to rho L over A. So we easily identify the letter L that represents the length. We easily identify letter A that represents the cross-sectional area. And what this symbol stands for?
Density?
Yes, we studied about that. That is known as density, but in this chapter, there is a specific term which we use for this symbol that is known as resistivity. So the term that we use for this symbol is known as resistivity, and the name of this symbol is known as rho. So the name of the symbol is rho, and the main purpose of using this symbol is to identify the resistivity. And what is resistivity? So you know that there are many type of conductors, right? There are different type of materials, there are different types of metals and conductors, right? And let's suppose if we take example of silver, copper, iron, diamond, and different materials are there. So normally we use copper and silver in our normal wirings, right? So basically this resistivity depends upon the capacity, or you can say that what will be the value of the resistivity of that specific wire or that specific conductor. Let's suppose if we take example of silver and copper, so इनमें से आपके पास बेस्ट कंडक्टर कौन सा है?
Copper?
Copper is the best conductor, right? So what do you think that the resistivity of copper is greater or less than silver?
Less than?
Less than silver. So each material has its own value of resistivity or resistance, right? Because each conductor or each material has its own flow of charges, and according to their structure, according to their conductivity, there is a specific value of resistivity in that, right? So we can say that resistivity depends upon the nature of material, depends upon the nature of conductor or material, right? So if we are using copper wire or a copper conductor in our circuit, so we know that the resistivity of the wire or the conductor will remain same throughout the experiment, right? Because during experiment हम वायर तो चेंज नहीं कर रहे, तो ये फैक्टर हमारे पास कांस्टेंट होगा, राइट? मोस्ट ऑफ द टाइम जब तक हम चेंज नहीं करते उसे, ठीक है? So that's why this factor remains constant. Otherwise, resistivity will also depends upon the, or sorry, resistance will also depend upon the resistivity, right? Because अगर आप बैड कंडक्टर यूज कर रहे हो तो आपको रेजिस्टेंस ऑटोमेटिकली हाई मिलेगी, ठीक है? और अगर आप गुड कंडक्टर यूज कर रहे हो तो आपको रेजिस्टेंस जो है वो ऑटोमेटिक लो मिलेगी, राइट? एनी कंफ्यूजन?
No, sir.
Okay. And if we discuss about the temperature, because in summer season we observed that many wires got short circuit due to high temperature. So what do you think, that resistance will increase with increase in temperature or decrease?
Increase?
Increase, right? So we can also write another factor that is not included in the formula, but that is a factor, because normally when we are performing experiment in our circuits, so there is not much effect of temperature because we perform experiment for a limited time interval. We are not perform experiment for many days, for many months. So that's why that factor is excluded from that formula, but that is also very important. So we can write that resistance will also increase resistance will also increase with increase in temperature, right? So resistance will also increase with increase in temperature, because we know that when we increase temperature, so what will happen if we increase temperature?
Particles collide more frequently?
Particles collide more frequently. So the overlapping or the hindrance will automatically increase with the increase in temperature, right? So अगर हम temperature increase करते हैं, so that will also change the vibration of particles, or you can say that the temperature will affect the vibrations, and that will create more hindrance, or you can say that the overlapping resistance will increase, right? So this is the most common reason and most common factor that how resistance will increase with temperature. Any confusion?
No, sir.
And insulators, so you know that insulators are not very good conductor, and due to their fixed positions of electron, we already discussed in electrostatics, right? conductors and insulators. And you remember that in insulators, electrons are fixed as compared to conductor, because conductor can move electrons freely, because electrons are free to move in conductors. So that's why in insulators, the current flow of current does not appear because of their fixed position, but conductor it is possible. But there are some factors on which current will also affect, or you can say that the flow of charges will affect due to resistance, right? Any confusion?
No, sir.
Okay. Now, if we discuss about a law which is related to voltage and electric current, there is a very basic law which is known as Ohm's law. Ohms is the SI unit of,
Electric charge?
no, for electric charge we use coulombs.
Resistance, sorry.
Yes, resistance. So basically, ohms is the SI unit of resistance. And what is Ohm's law and what actually Ohm's law is related with? Because we know about now potential difference, we know about electric current, we also know about the resistance, right? So we can say that the current flowing through a metal conductor is directly proportional to the potential difference if physical condition and the temperature of the conductor remains constant, right? So we can write the statement for that, because it is very important law that will help you to solve many questions. So we can write Ohm's law as current through the conductor is directly proportional to what? किसके डायरेक्टली प्रोपोर्शनल होगा?
Charge?
Potential, right? So it's very important law and very important relation between current and voltage. It helps you to solve many problems or questions related to electric current. So it is directly proportional to the potential difference across the end of the conductor, across the end of the conductor. And there is a condition, and condition is that if physical condition and temperature remains constant, and this is very important term, physical condition and temperature remains constant, because it's continuously increasing. Let's suppose there is a wire and current is passing through that, and you supply continuously supplying thermal energy, right? So what will happen, that thermal energy will increase the resistance, right? And due to increase in resistance, the flow of current will decrease. So if physical condition and temperature of the conductor remains same or constant, ठीक है, आप कंटिन्यूसली करंट करवा रहे हो किसी वायर से, और सपोज आपने वायर को बीच में से ब्रेक कर दिया, वायर को आपने स्पाइरल कर दिया, वायर को आपने राउंड कर दिया, फोल्ड कर दिया, so that will affect the value of electric current, right? And if you increase the temperature of the wire, so that will also affect the electric current, right? So that's why this factor is very much important. that these two conditions will remain constant. Otherwise, the value of electric current and potential difference or voltage will get affected with these two factors, right? Okay, any confusion?
It's clear, sir.
Okay, and if we write formula for it, so the relation or the formula for this law is equal to current is directly proportional to voltage, and since physical condition and temperature remains constant, so it means the resistance will also remains constant, because now there is a factor of wire which is already constant. So we can say that we already know, we written in our previous class, that resistance is the ratio of voltage and electric current, right? So we can write this one as V over I is equals to resistance. So resistance is a constant factor here. If resistance remains constant, then current will directly proportional to the voltage or potential, or in other form we can write as V I R. This is the final formula, right? So V is equals to IR is the final equation or the final equation for our Ohm's law, right? Any confusion?
No, sir.
Okay. Now these are the topics which are related to current, resistance, and potential difference. We also discuss about the factor affecting. And if someone asks you to draw a graph for Ohm's law, so what is the graphical representation for Ohm's law? If we want to draw a graph for Ohm's law, so any idea how graph is going to be for Ohm's law? Let's suppose if voltage is on y-axis or x-axis, let's suppose if there is a wire and current is passing through it, and let's suppose there is a value of voltage there and there is a value of electric current there, and we need to draw a graph for it, and we place voltage on x-axis and electric current on y-axis. So what will be the value and what will be the graph, and how you are going to draw graph for V directly proportional to I? Let's suppose if we draw a vertical, so this is our y-axis, this is our x-axis. तो आइडेंटिफाई कर सकते हो ग्राफ किस डायरेक्शन में जाएगा हमारे पास? अगर लेट्स सपोज मैं यहाँ पे मार्क करता हूँ वोल्टेज को और यहाँ पे मार्क करता हूँ मैं इलेक्ट्रिक करंट को, एंड बोथ आर डायरेक्टली प्रोपोर्शनल, सो व्हाट विल बी द डायरेक्शन ऑफ द ग्राफ?
It will be constant.
Constant, or you can say that if we start value from 0, so it will move in a straight direction like a constant speed graph, right? So it means that both values are increasing with equal ratio. And let's suppose if someone asks you about that, what will be the gradient of this graph and which quantity will you get from the gradient of this graph? So if we want to calculate the gradient, let's suppose we are calculating the gradient from this graph, which is the ratio between V over I. So what is the value of gradient, or which quantity are you going to be calculate from the gradient of the graph? कौन सी कैलकुलेट क्वांटिटी कैलकुलेट कर पाएंगे हम ग्रेडियंट से? एनी आइडिया? पोटेंशियल डिफरेंस,
Nothing.
इलेक्ट्रिक करंट, रेजिस्टेंस,
A
anything,
potential difference?
but that is already mentioned in the graph. We can easily identify the value of potential difference from the graph because that is specifically mentioned there. So we don't need to calculate that one. Current is also there.
Resistance?
Resistance, right? Because V over I is the ratio of resistance. So if someone asks you that what will you get from the gradient of this graph, so your answer will be resistance, that we will get the value of resistance from this graph, right? Let's suppose if I mark values here, let's suppose voltage is increasing with 5 and it is increasing with 2 here. So let's suppose if you want to calculate a value of resistance over point, so what will be the value of resistance?
5?
5.
Oh, 4 over 10?
So R is equals to 10 over 4 or 4 over 10?
10 over 4.
10 over 4. So 10 over 4 is the value and the accurate answer will be equal to 2 point something, 2.5, and the SI unit of resistance is equals to ohms, right?
Yes.
So this is the basic concept of resistance, that we can also calculate resistance with the help of current and voltage graph, that is known as Ohm's law, right? Any confusion?
No, sir.
Okay. And if you want to draw a symbol for, let's suppose, because in current electricity there is a specific symbol, or you can say that electrical symbol for each component. So if you want to draw electrical symbol for resistor, so what will be the electrical symbol for resistor? So you need to remember the symbol of each component, because there is one quantity we discuss of current, voltage, and you already know about the this symbol plus minus represents what? ये प्लस माइनस किस कंपोनेंट को रिप्रेजेंट कर रहा है?
The charge?
और कंपोनेंट क्या होगा? चार्ज तो हमारे इंटरनल पार्टिकल्स हो गए, ये चार्जेस कहाँ से पास होंगे? अ सेल और अ बैटरी, राइट, और पावर सप्लाई. So this symbol is used for cell, battery or power supply, right? So हमें इलेक्ट्रिकल डायग्राम से आइडिया लेना होगा कि इलेक्ट्रिकल डायग्राम किसे रिप्रेजेंट कर रही है. So this plus minus represents cell, battery or power supply, right? And if you want to draw, because I already draw a diagram for lamp over here, because when we start chapter of electrical circuits, then we will study about each and every symbol again. But in this chapter, at least we need to know about the symbol of those components which we studied in this chapter, right? So let's suppose if we want to draw an electrical symbol for resistor, so you just simply need to draw a rectangle box like this. So this is the electrical symbol for resistor, but there is also a variation in it, that this symbol is used for fixed resistor, is the value of the resistor is fixed, right? And what happens if we used a variable resistor? So what will be the diagram for variable resistance? because we sometimes use a device resistance are there. We need to draw a second diagram for that, and for the diagram will be like this. So this symbol represents variable resistor, right?
Yes.
So हम फर्दर क्वांटिटीज चैप्टर्स जिस तरह से डिस्कस करते जाएंगे, ये क्वांटिटीज यूज टू होती जाएंगी और ये सिंबल्स भी यूज टू होते जाएंगे, तो फिर इतना डिफिकल्ट नहीं होगा। अभी फर्स्ट टाइम है, तो अभी सिर्फ दो सिंबल्स याद रखने हैं आपने, पावर सप्लाई, सेल और बैटरी, और सेकंड जो है वो रेजिस्टर्स के लिए, राइट। और लैम्प के लिए सर्कल जो है वो आपके पास क्रॉस में होगा, ये हम ऑलरेडी डायग्राम्स में ड्रॉ करके देख चुके हैं। एनी क्वेश्चन?
No, sir, it's clear.